Let us find the limit as x approaches 3 f of x for this piecewise different function. Now, this function has two pieces. F of x is equal to 3 minus x when x is less than 3, meaning below 3, the f of x is 3 minus x. When x is greater than 3, f of x equal to square root of x minus 3. So when x is above 3, the function is square root of x minus 3. So 3 serves as a boundary between these two functions. So when you want to find the limit at such a point, we need to find the left limit and the right limit. So therefore, we want to find the limit x approaches 3 negative f of x. We want to know how much is that. And also we want to find limit x approaches 3 positive f of x. Now, as x approaches 3 from the left, your function is given by 3 minus x. So 3 minus x approaches 3 minus x, which is 3, or 0. Now, as x approaches 3 from the right, the function is square root of x minus 3, which will approaches x goes to 3, 3 minus 3, or square root of 0, which is 0. Now, the left limit is 0 and the right limit is 0. Therefore, limit x approaches 3 f of x is equal to 0. Now, if you look at the graph of f of x, here is the graph of f of x. When x is less than 3, the graph is a straight line, which is f of x equal to 3 minus x, which is a straight line with slope of negative 1 and y-intercept of 3. And when x is above 3, the graph is square root of x minus 3. Clearly, both here as x approaches 3, the graph actually approaches 0. Now let's find the limit as x approaches 4 of g of x for this piecewise function g of x. Again, you can see this has two pieces, and the 4 separate these two pieces. Now when x is less than 4, the function is given by x squared minus 3. When x is greater than or equal to 4, the 4 and above 4, the function is square root of x minus 4. Now again, 4 separate these two functions, mean we need to find the left limit and the right limit. So we need to find limit as x approaches 4 negative of g of x and x approaches 4 positive of g of x. Now as x approaches from the left, f of x approaches 4 squared minus 3, which is 16 minus 3, or 13. Now as x approaches from the right, this is your function, so which approaches square root of 4 minus 4, or 0. Now the left limit is 13, but the right limit is 0. Therefore limit x goes to 4, g of x does not exist. Now here is the graph. So this part is x squared minus 3, and this part of the graph is square root of x minus 4. Here, as x approaches 4, this part approaches this one is 13. So x approaches 4, this approaches 0, as you see here. Let us find the limit as x approaches 0, absolute value of x over x. Now, we know the definition of absolute value of x. So the absolute value of x is actually negative x if x is less than 0 and x if x is greater than or equal to 0. Therefore, absolute value of x over x is equal to negative x over x when x is negative, and x over x when x is greater than or equal to 0. However, if you look at the function, x denominator becomes 0 when x equal to 0. That means the domain of this function is all real numbers except 0. So we should ignore 0. That means x is greater than 0. That is equal to, so absolute value of x over x is negative x over x, which is negative 1 if x is negative, and x over x, which is 1 if x is greater than 0. So that means absolute value of x over x is a piecewise defined function. So therefore we need to find the left limit and the right limit. That means we want to find the limit as x goes to 0 negative, absolute value of x over x. So which is the limit x goes to 0 negative of when x is less than 0. 0 negative mean the below 0, mean x is less than 0 of. So absolute value of x over x equal to negative 1. Therefore, as x goes to 0 from the left of negative 1, so negative 1 has nothing to do with x. Therefore, this is equal to negative 1. And the right limit, so limit x goes to 0 plus absolute value of x over x, which is equal to limit x goes to 0 plus, mean above 0, x is greater than 0. When x is greater than 0, absolute value of x over x is equal to 1. Since again as 1 has nothing to do with x, the limit is equal to 1. Now what we see is the left limit is negative 1, the right limit is 1. Therefore, limit x goes to 0, absolute value of x over x does not exist. It does not exist. Now, if you look at the graph of absolute value of x over x, now it is negative 1 when x is less than 0, so it looks like this, and at 0 is not defined, and it is positive 1 when x is greater than 0. This is the graph of absolute value of x over x. As you see, the left limit is negative 1, the right limit is 1, therefore limit does not exist. Let us discuss about the piecewise function called greatest integer function. The notation we use is, say function is f of x is integer x, or f of x is using this symbol. It's called the greatest integer function. This means the largest integer less than or equal to less than or equal to x. For example, what is the largest integer? Less than equal to 1. We know it is equal to 1. If we have a doubt, we can draw the x-axis. This is 0, 1, 2, like that. So the largest integer less than equal to 1 is the 1. And what is the largest integer of 1.8? So 1.8 is somewhere over here. So the largest integer less than equal to that is equal to still 1. Now what is the greatest integer of 2? So that's over here. So the largest integer that is less than equal to 2 is equal to 2. Now you can see how it works, and that is how you get this graph. So when x is 0, greatest integer is 0. Between 0 to 1, it's always 0. And at 1, it becomes 1. And jump over here. And then up from 1 to 2, it's 1. And at 2, it jump into 2, and so on. Now suppose we want to find the limit as x approaches, say, 3 integer x. As you see, as x approaches 3 from the left side, its value is 2. As x approaches 3 from the right side, the value is 3. Therefore, the limit does not exist. Limit does not exist because the left limit as x approaches 3 from the left, which is equal to 2. As x approaches 3 from the right, integer x is equal to 3. So the left limit is not equal to the right limit.